Welcome to Trivia Fusion. Today, we're going to unravel the mysteries of one of the most mesmerizing natural phenomena on Earth, the Aurora Borealis, also known as the Northern Lights. If you've ever seen photos or videos of these breathtaking lights dancing across the night sky, you've probably wondered how they come to be. Sit back and get ready to learn about the science behind the Aurora Borealis, as well as some fascinating facts about this incredible display. The Aurora Borealis occurs in the polar regions and is most commonly seen in high-latitude areas around the Arctic, although its southern counterpart, the Aurora Australis, can be seen near the South Pole. The term Aurora Borealis comes from the Roman goddess of dawn, Aurora, and the Greek name for the north wind, Boreas. Together, they perfectly capture the ethereal beauty of this natural light show. But what causes these lights to appear? To understand the Aurora Borealis, we need to start with the sun. The sun, our closest star, is a massive ball of burning gases, primarily hydrogen and helium, undergoing nuclear fusion. This fusion process releases a tremendous amount of energy, including light, heat, and solar wind, a stream of charged particles, like protons and electrons that continuously flow out from the sun into space. This solar wind is the first key ingredient in the formation of the Aurora Borealis. As the solar wind travels through space, it eventually reaches Earth. Our planet is protected by a magnetic field generated by the movement of molten iron within its core. This magnetic field acts like a shield, deflecting most of the solar wind away from the Earth. However, at the poles, the magnetic field lines converge and create openings where the charged particles can enter the Earth's atmosphere. These openings are known as the polar cusps. When the charged particles from the solar wind enter the Earth's atmosphere, they collide with atoms and molecules of gases like oxygen and nitrogen. These collisions occur at altitudes between 60 to 400 miles above the Earth's surface. When the charged particles strike the gas atoms and molecules, they transfer their energy, exciting these atoms and causing them to move to a higher energy state. When the excited atoms return to their normal state, they release this excess energy in the form of light. This emission of light is what we see as the Aurora Borealis. The colors of the Aurora Borealis depend on the type of gas being excited and the altitude at which the collisions occur. Oxygen atoms, for instance, can produce green or red auroras. Green auroras are the most common and occur at altitudes of around 60 to 150 miles, while red auroras, which are less common, occur at higher altitudes above 150 miles. Nitrogen molecules, on the other hand, can produce blue or purplish, red auroras, depending on the energy level of the collisions. The auroras often appear as shimmering curtains of light that can stretch across the sky. This shape is due to the way the Earth's magnetic field lines guide the charged particles. As the particles spiral along the magnetic field lines, they create long, narrow bands of light that seem to dance and shift. Sometimes, the auroras can form arcs, spirals, or even corona-like shapes, adding to the visual spectacle. The intensity and frequency of the Aurora Borealis are influenced by the sun's activity. The sun goes through an 11-year cycle of varying solar activity, known as the solar cycle. During periods of high solar activity, known as solar maximum, the sun produces more solar wind and solar flares. Sudden, intense bursts of radiation. These solar flares can send massive amounts of charged particles towards Earth, increasing the likelihood of auroral displays. Conversely, during periods of low solar activity, known as solar minimum, auroras are less frequent and less intense. One of the most dramatic manifestations of increased solar activity is a geomagnetic storm. These storms occur when a particularly strong burst of solar wind interacts with the Earth's magnetic field, causing disturbances that can enhance the auroras. During a geomagnetic storm, the Aurora Borealis can be seen at much lower latitudes than usual, sometimes even as far south as the United States or southern Europe. These events provide a rare opportunity for people living outside the polar regions to witness the northern lights. The Aurora Borealis has fascinated humans for centuries and has been the subject of many myths and legends. In ancient times, people often interpreted the lights as supernatural phenomena. The indigenous Sami people of Scandinavia believed that the auroras were the energies of the spirits of the dead, while the Inuit of Alaska thought the lights were the souls of animals like seals, salmon, and deer. In medieval Europe, auroras were sometimes seen as omens of war or disaster. In addition to being a source of wonder and inspiration, the Aurora Borealis can also have practical implications. For example, the charged particles that create auroras can interfere with radio and satellite communications, GPS signals, and even power grids. During intense geomagnetic storms, these disruptions can become significant, posing challenges for modern technology. Scientists study the auroras not only to understand their beauty, but also to predict and mitigate these potential impacts. One of the most exciting aspects of studying the Aurora Borealis is the opportunity to use advanced technology to observe and understand this phenomenon. Ground-based observatories equipped with special cameras and sensors capture stunning images and videos of the auroras. Satellites orbiting the Earth provide a broader perspective, allowing scientists to study the interactions between the solar wind and the Earth's magnetic field from space. Instruments like magnetometers measure changes in the magnetic field, providing valuable data on geomagnetic activity. Scientists also use computer models to simulate the behavior of the Earth's magnetic field and the solar wind. These models help researchers predict when and where auroras are likely to occur and understand the complex processes that drive them. By combining observations, measurements, and simulations, scientists continue to uncover new insights into the mechanisms behind the Aurora Borealis. For those fortunate enough to witness the Aurora Borealis in person, the experience is unforgettable. The best time to see the northern lights is during the winter months when the nights are long and dark. Locations within the Arctic Circle, such as northern Norway, Sweden, Finland, Iceland, and Canada, are prime spots for aurora watching. However, during periods of high solar activity, the auroras can be visible much farther south. To maximize your chances of seeing the Aurora Borealis, it's essential to find a location with clear, dark skies away from city lights. Checking the aurora forecast, which predicts geomagnetic activity based on solar observations, can also help you plan your viewing. Many websites and apps provide real-time updates on aurora conditions, making it easier than ever to catch a glimpse of this natural wonder. In addition to the visual spectacle, the Aurora Borealis can also produce sounds, although this is a subject of ongoing research and debate. Some people have reported hearing faint crackling or rustling noises during intense auroral displays. Scientists are still investigating the origins of these sounds, but one theory suggests that they may be caused by charged particles interacting with the Earth's magnetic field at lower altitudes, producing audible electromagnetic waves. The Aurora Borealis is not only a beautiful phenomenon, but also a reminder of the dynamic and interconnected nature of our solar system. The interplay between the Sun and the Earth creates these stunning light displays, showcasing the power and complexity of the forces at work in the universe. By studying the auroras, we gain a deeper appreciation for the natural world and the many ways in which our planet is influenced by its cosmic surroundings. As we continue to explore and understand the Aurora Borealis, we also open up new possibilities for scientific discovery and technological advancement. For example, understanding the interactions between solar wind and the Earth's magnetic field can help us develop better space weather forecasting systems, which are crucial for protecting our satellites, astronauts, and technological infrastructure. The insights gained from studying auroras can also inform our understanding of other planets and moons in our solar system that experience similar phenomena, such as Jupiter and Saturn. The Aurora Borealis serves as a bridge between the ancient and the modern, the mystical and the scientific. It has captivated the human imagination for millennia and continues to inspire awe and wonder in those who witness its splendor. Whether you're a seasoned aurora chaser or someone seeing the northern lights for the first time, the experience is a powerful reminder of the beauty and majesty of the natural world. In conclusion, the Aurora Borealis, or northern lights, is a stunning natural phenomenon caused by the interaction between the solar wind and the Earth's magnetic field. Charged particles from the sun collide with gases in the Earth's atmosphere, creating vibrant displays of light in various colors. The intensity and frequency of auroras are influenced by the solar cycle and geomagnetic activity. The auroras have inspired myths and legends throughout history and continue to captivate scientists and the public alike. By studying the Aurora Borealis, we gain valuable insights into the dynamics of our solar system and the interconnectedness of the natural world. So, the next time you find yourself under a clear, dark sky in a high-latitude region, keep an eye out for the magical dance of the northern lights. Thanks for watching Trivia Fusion. Don't forget to like, share, and subscribe for more awesome facts about the wonders of our world. Stay curious, and we'll see you in the next video.